morning students, this is Anjali, Assistant Professor, Department of CSE, AIML, IARE, Hyderabad. Today's our topic is problems on bias theorem. So, we will take one by one examples. Example 1 is that three person ABC have applied for a job in a private company and the chance of their selection is the 1:2:4. The probability is that ABC can introduce changes to improve the profits of the company are 0.8, 0.5 and 0.3 respectively. Now, if the change does not take the place, find the probability that it is due to the appointment of C. Now, here you can see that E1 is showing that person A get the selected, E2 is showing that person B gets selected, and E3 is showing that person C gets selected. Now, here A we can check changes introduced but profit not happened. Now, here we have to find out probability of probability of E1. 1 divided by 1 plus 2 plus 4, that is 1 by 7, and probability of E2 is 4 by 7. Now, probability of A given E1 is equal to, we can say that probability of profit not happened by the changes introduced by A. Now, here you have to find out, you have to keep the formula, that is 1 minus P of profit happened by the changes introduced by A. Now 1 minus 0.8, that is 0.2, and probability of A given E2. Now here probability of profit not happened by the changes introduced by B, and here 1 minus probability of profit happened by the changes introduced by B. Now 1 minus 0.5, that is 0.5. Again, you can see here probability of A given E3. Probability of profit not happened by the changes introduced by C, and 1 minus probability of profit happened by the changes introduced by C. Now again is equal to 1 minus 0.3 is equal to 0.7. Now we have to find out the probability of not happening profit due to the selection of C. Now here we have to use the formula probability of E3 given A. Now our formula is probability of given E3 into probability of E3 divided by probability of A given E1, probability of E1 plus probability of A given E2, probability of E2 plus again probability of A given E3, probability of E3. Now, after keeping all values, you will get the answer 7 by 10. So, required probability is that 0.7. Now, second question is that a bag contains 4 balls. 2 balls are drawn at random without replacement and are found to be blue. What is the probability that all balls in the bag are blue? Now, even B, the bag contains 2 blue balls, E2 bag contains 3 blue balls, and E3 bag contains 4 blue balls. Now, event A is saying that event of getting 2 white balls. Now, here probability of E1, probability of E2 and probability of E3 will be same, that is 1 by 3. Now, probability of A given E1 is equal to C2 by C2. So, after solving it 1 by 6, again here you have to use the combination. Then probability of A given E2, that is 1 by 2, and probability of A given E3, that is 1. Now, probability of E3 given A, its answer will be 3 by 5. Now, example 3 is that in neighborhood, 90% children were falling sick due to flu and 10% due to measles. and no other disease. And the probability of observing rashes for measles is 0.95 and for flu is 0.08. If child develops rashes, find the child's probability of having flu. Now again, we will consider F as a children with flu, M as a children with measles, and R children showing the symptoms of rashes. Now here, probability of F, it's given, that is 90%. Probability of M, 10%. Obviously, if probability of F is a 90%, so probability of M will be 10%. So probability of R given F, that is 0.08, and probability of R given M, that is 0.95. So here we will use the formula probability of F given R, that is probability of R given F into probability of F divided by probability of R given M into probability of M. So plus probability of R given F into probability of F. So after solving this formula, these values, these questions, you will get the probability of F given R, that is 0.43. Now question 4 is that there are 3 identical cards except that both the sides of the first card is colored red, both sides of second card is colored blue, and for the third card one side is colored red and the other side is blue. Now one card is randomly selected among these 3 cards and put down. Now visible side of the card is red. Now you have to find out the probability that the other side is blue. Now here you have to consider RR, that is card with both sides red, BB, that is card with both sides blue, RB, card with one side red and other side blue. So here event A is that the visible side of the chosen card is red. Now here probability of RR, it will be 1 by 3, probability of BB, that is a 1 by 3, and probability R by B, probability RB, that is 1 by 3. Now by theorem, by using the theorem, you will get the total probability. So P of A is equal to P of A given RR into probability of RR plus P of A given BB into probability of BB, and the probability of A given RB into probability of RB. Now you have to solve this and you will get the value of P of A, that is 1 by 2. So now again probability of RB of A, we have to find out the probability that other side is blue. So here probability of RB, one side is red, another side is blue, given event A. Here we will use probability of RB intersection A divided by probability of A, and is equal to probability of A intersection probability of RB, that is divided by probability of A. So we will solve this problem. We are getting the formula like probability of A given RB into probability of RB divided by probability of A. So after solving, you will get the answer 1 by 3. Now next example is that 3 urns are there containing white and black balls. First urn has 3 white and 2 black balls. Then second urn has 2 white, 3 black balls. Second urn has 2 white and 3 black balls. And third urn has 4 white and 1 black ball. Now without any biasing, one urn is chosen, from that one ball is chosen randomly which was a white. What is the probability that it came from the third urn? Now even is that event that the ball is chosen from first urn. E2, event that the ball is chosen from second urn. E3, event that the ball is chosen from third urn. And so event A is that the chosen ball is white. Now now probability of E1, probability of E2 and probability of E3 is a 1 by 3. Probability of A given E1, that is 3 by 5. Probability of A given E2, that is 2 by 5, and probability of A given E3, that is 4 by 5. So again we are getting the formula probability of E3 given A. Here we will use the formula probability of A given E3 into probability of E3 divided by probability of A given E1 into probability of E1 plus probability of A given E2 into probability of E2 plus probability of A given E3 into probability of E3. So now you have to keep all the values, and after keeping all values you will get the answer 4 by 9. Now next question is that it is observed that 50% of mails are spam. There is a software that filters spam mail before reaching the inbox. Now its accuracy for detecting a spam mail is 99% and chances of tagging a non-spam mail as a spam mail is 5%. If a certain mail is tagged as spam, find the probability that it is not a spam mail. Again, we will consider E1, that is event of spam mail, E2, event of non-spam mail. So, event A, detecting a spam mail. So, here probability of E1 that is 0.5 and probability of E2 that is 0.5. Now, probability of A given E1 is equal to 0.99 and probability of A E2 given 0.05. You have to find out the probability of E2 given A, that is that it is not a spam mail. Here you have to use probability of E2 given A is equal to probability of given E2 into probability of E2 divided by probability of A given E1 and probability of E1 plus probability of A into E2. So all values you have to put in the formula, and after solving you will get the value 4.8%. Now next question is that an unbiased dice is rolled and for each number of the dice a bag is chosen. Bag A contains 3 white ball and 2 black ball. Bag B contains 3 white ball, 4 black ball, and bag C contains 4 white ball and 5 black ball. Dice is rolled and bag is chosen. So if white ball is chosen, find the probability that it chosen from the bag B. There are number on the dice and bag chosen. Number on the dice 1, bag chosen bag A. Number on the dice 2 or 3 for its bag B, and number on the dice 4, 5 or 6, that is bag C. Now solution is that here E1 will be the event of choosing bag A, E2 event of choosing bag B, and E3 event of choosing bag C. Now A, event of choosing white ball, that is first P of A, P of E1 is equal to 1 by 6, P of E2 2 by 6, and P of E3 that is 3 by 6, or we can say 1 by 2. Now probability of A given E1 that value is 3 by 5. Probability of A given E2 that value is 3 by 7, and probability of A given E3 that value is 4 by 9. So probability of E2 given A we have to find out. After that we will keep all values in the bias theorem. Probability of A given E2 into probability of E2 divided by probability of A E1 into probability of E1 plus probability of A given E2 into probability of E2 plus probability of A given E3 into probability of E3. So after that, if you got every value and you have to put all values in the formula. By solving this, probability of E2 given A, you will get the 90 by 293. Now next question is that a insurance company has insured 4,000 doctors, 8,000 teachers and 12,000 businessmen. Now the chances of a doctor, teacher and businessman dying before the age of 58 is 0.01, 0.03 and 0.05 respectively. If one of the insured people dies before 58, So find the probability that he is a doctor. Now here again we will consider the three events E1, E2, E3. And E1 is showing that event of person being a doctor, E2 event of person being a teacher, and E3 event of person being a businessman. Now A is showing event of death of an insured person. So probability of E1 is equal to 4000 divided by 4000 plus 8000 plus 1200, that is after solving you are getting 1 by 6. Then probability of E2 you are getting the 1 by 3. And probability of E3 it's getting 1 by 2. Now probability of A given E1 that is 0.01. Probability of A given E2 that is 0.03. And probability of A given E3 that is 0.05. Now you have to keep all the values in the Bayes theorem formula. So the formula is that probability of E1 given A is equal to probability of A given E1 into probability of E1 divided by probability of A given E1 into probability of E1 plus probability of A given E2 into probability of E2 and probability of A given E3 into probability of E3. So all these values, now you have all the values and you have to keep all values in the formula. After solving you will get the 1 by 2, 1 by 22. Now next question is that a card is lost from a pack of 52 cards. Now from the remaining cards, 2 are drawn randomly and found to be the both clubs. Find the probability that the lost card is also a club. Now E1 is showing lost card is a club. E2 is showing lost card is not a club. Now A is that both drawn cards are the club. Probability of E1 is 13 by 52. Probability of E2 that is 39 by 52. So probability of A given E1 is equal to probability of drawing both club cards when he lost a card is club. That is 12 by 51 into 11 by 50. Why we are taking the 51? Because already one of the club card is lost. And we have selected one club card. So after that we got the only 50 number. So next one is that we are getting probability of A given E2 that is probability of drawing both club cards when the lost card is not the club. That is 13 by 51 into 12 by 50. Now probability of E1 given A is equal to probability of A given E1 into probability of E1 divided by probability of A given E1 into probability E1 plus probability of A given E2 into probability of E2. After keeping all values and after solving this, you will get the answer probability of E1 given A is equal to 11 by 50. Now next problem is that in shop A, 30 tin pure ghee and 40 tin adulterated ghee are kept for sale while in a shop B. 50 tin pure ghee and 60 tin adulterated ghee are there. Now 1 tin of ghee is purchased from one of the shops randomly and it is found to be adulterated. Find the probability that it is purchased from shop B. Even here, let even be the event of choosing shop A, E2 event of choosing shop B, and event A of purchasing adulterate tin of the ghee. Probability of E1 is equal to 1 by 2. Probability of E2 is equal to 1 by 2. Now probability of A given E1 purchasing adulterate ghee from the shop A, that is 40 by 70, and probability of A given E2 P of purchasing adulterated ghee from shop B, that is 60 by 110. So after solving, we are getting the answer 6 by 11. Now here we will keep all values and we will find out the probability of A2 given A, that is probability of A given E2 into probability of E2 divided by probability of A given E1 into probability of E1 plus probability of A given E2 into probability of E2. So here after solving this formula, these values, you will get that 21 by 43. Now next question is that 3 identical boxes contain red and white balls. First box contains 3 red, 2 white balls, and second box has 4 red, 5 white balls, and third box has 2 red and 4 white balls. So a box is chosen very randomly and a ball is drawn from it. If the ball that has drawn out is a red, what will be the probability that the second box is chosen? Now let A1, A2, A3 represent the events of choosing the first, second and third box respectively. And let X be the event of drawing a red ball from the chosen box. Then we are to find the value of P, that is the value of probability A2 given X. Now there are 3 boxes which are identical. Probability of A1 is equal to probability of A2, probability of A3, that is 1 by 3. Now again, probability of X given A1, that is 3 divided by 3 plus 2, so 3 by 5. Probability of X divided by probability of X given A2, that is 4 divided by 4 plus 5, 4 by 9, and the probability of X given A3, that is 1 by 3. Now X occur if one of the mutual exclusive and exhaustive events are A1, A2, A3 occurs. So by using the Bayes theorem formula, we can get the answer, that is 10 by 31, but we will use the formula like probability of A2 given X is equal to probability of A2 into probability of X given A2. Again divided by, here we will add probability of A1 into probability of X given plus probability of A2 plus A2 into probability of X by X given A2 plus probability of A3 plus probability of X given A3. So all values we will keep in this formula, and after solving these values, this equation, you will get the value 10 by 31. Now next question is that 2 urns contain respectively 2 red, 3 red, 5 white balls, and 1 ball is drawn at random from the first urn and transferred into the second one. Ball is then drawn from the second urn and it turns out the ball is red. What will be the probability that transferred ball was the white? Now here A1 and A2 denote the events that transferred ball from the first urn to the second is white and red respectively. Now here probability of A1, that is 3 by 2, and probability of A2, that is 2 by 5. So again let X denote the drawing a red ball from the second urn after the occurrence of A1 or A2, and then we are to find the value of probability of A1 divided by given X, that is 3 by 9, and probability of X given A2, that is 4 by 9. Now here X is occurring. So if the mutual exclusive and exhaustive events A1 and A2 occurred, so we can take the Bayes theorem and we will keep all values in the Bayes theorem, and after solving this formula, you will get the answer 9 by 17. Again, next question is that in a bolt factory, there are 3 machines M1, M2 and M3 manufacture 2000, 2500 and 4000 bolts every day. Of their output, 3%, 4% and 2.5% are defective bolts. But one of the bolts is drawn very randomly from a day's production and is found to be defective. What is the probability that it was produced by machine M2? Let A1, A2 and A3 denote the events that the randomly drawn bolt from the day's production was manufactured by machines M1, M2 and M3 respectively. Now if X is the event that the drawn bolt is defective, then we are to find the value of probability A2 given X. Here probability of A1 that is 4 by 17, probability of A2 5 by 17 and probability of A3 5 by 8 by 17. Now again probability of X given A1 that is 3 by 100, probability of X given A2 4 by 100 and probability of X given A3 that is 2.5 by 100. So here event X can occur if one of the mutual exclusive and exhaustive events occur, A1, A2 and A3 occurs. So therefore we can use here Bayes' theorem formula. And by using this formula, we can solve this and we will get the answer 5 by 13. So this is all about the Bayes' theorem, problems on the Bayes' theorem. These are the references, so you can go through this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.